The last section in chapter 3 is chapter 3, section 7. So we've already talked about the first part of this chapter. So now we're going to talk about the last part of the chapter. So the first thing we're going to talk about in this last video is evaporation, boiling, and condensation. So evaporation occurs when a liquid is converted to a gas, so that's a state change, and some of the gas, when it's boiled, actually has enough energy to come off the surface of the liquid. So you see this anytime that you boil water, for example. So when you add heat to a liquid, it turns to a gas, and that's called vaporization. And once that gas starts to cool, if you remove heat, then the gas will condense. So it'll go back to a liquid form. So these transitions are all state changes. Another state change occurs when you go directly from a solid to a gas, and that's known as sublimation. The exact opposite, or the reverse of that, is going from a gaseous state to a solid state, and that's known as deposition. Okay, so from these things, we also need to talk about heat of vaporization. So instead of melting or freezing, in this case, we are boiling or subliming and then condensing or depositing. So the heat of vaporization is defined as the energy that must be added to convert exactly 1 gram of liquid to gas at its boiling point. Okay, so for water, just like we talked about last time, the heat of vaporization for water is 540 calories for 1 gram of water, or 2,260 joules for 1 gram of water at its boiling point, which is 100 degrees C. Okay, so then we can use these numbers as conversion factors. So again, we can write them either way, 540 calories per 1 gram, or 1 gram per 540 calories, vice versa. So either one of these units is a unit of energy, just like we talked about in the previous videos, calories and joules. So now let's do some practice. So if we need to calculate the heat to vaporize or condense water, we would need a formula. That formula is heat equals mass times the heat of vaporization. So we always need to know how much substance we're starting with. So this example, so we'll do an example problem, says in a sauna, 122 grams of water is converted to steam at 100 degrees Celsius. So steam is gaseous water. How many kilojoules of heat are needed? Okay, so here is our formula. I'm going to highlight that, and then let's do this problem. So we're given 122 grams, which is our mass, and we also know the heat of vaporization for water is 2,260 joules per 1 gram. Okay, so we know our formula, heat equals mass times heat of vaporization. Alright, so we know those two things, so we can plug those numbers in. So 122 grams times 2,260 joules per 1 gram. Okay, so now we know we have grams on the top and grams on the bottom, so those cancel. So we are left with joules, which is the unit that we need because we know joules is a unit of energy and heat is thermal energy. So if we do that math, 122 times 2,206, we get 275,720 joules. Now we need to look at our sig figs. So this number has 3 significant figures, and this number also has 3 significant figures. So our answer needs to be 3 sig figs. So I'm going to go ahead and mark our third significant figure here. But it wants our answer in kilojoules. Okay, so we need to convert to kilojoules. Okay, so if you think back to your prefixes, 1 kilojoule equals 1,000 joules, which is the same as 10 to the third joules. Okay, so our joules need to go in our denominator to get our units to cancel because we have joules in our numerator here. 1 kilojoule goes on top, so now our joules cancel, so we're left with kilojoules. So when we divide 275,720 by 1,000, we get, so I'm going to have to write it above where we converted, 275.72 kilojoules. And again, we had marked our significant figures. So after rounding our answer, so we look at our last sig fig and look at the number directly to the right and decide if we need to round up or down. So we need to round up since the next number is a 7. So we get 276 kilojoules as our final answer. Okay. So the very last part of this section talks about heating and cooling curves. So that's what I'm showing here on this slide. So as heat is absorbed, we start with our solid. So in this case, they're showing solid ice. So as the temperature increases, the ice gets to the melting point of water. So at that point, the ice begins to melt. As temperature increases, our ice is completely converted into liquid water. And as the temperature increases over the curve, then eventually it's going to reach the boiling point of water, which is 100 degrees Celsius. So at this point, the water has started boiling. So it's going to stay at one temperature for a while. It's just going to boil. And then at a certain point, the water molecules will get enough energy and will turn to gas. So then we get our steam or water vapor, and as our temperature increases, then the temperature of the gas increases. So that's why our heating curve keeps going up there. So heat absorbed is on our x-axis and temperature is on our y-axis. So the cooling curve is just the exact opposite of the heating curve. So now we're removing heat, and as our temperature decreases, we go from steam to water and steam, which is boiling. So now we're at the boiling point of water. And then as that water cools even further, then we're converted back completely to liquid water. And as the temperature goes down, we get to the freezing point of water. So now we are converting our water into ice. And finally, once the temperature drops below the freezing point, we have completely converted to all solid water or ice. Okay, so just remember areas on this graph. So where it's a solid, where it's a liquid, and where it's a gas, and at what point indicates melting and boiling. So now we're going to look at a heating curve and see if we can place all of these cups and match them to the letters. Okay, so here we're starting at negative 20 degrees. So A is below the freezing point of water. So we know we have solid water, and the only cup that has just solid water is 3. So this is going to be A. Okay, so that's solid water. And B, this is our point where we begin to melt water, or I'm sorry, melt ice. So the water has begun to turn liquid in this case. So here in this cup we have some ice and some water. So that shows us that our ice has started melting. So this is B. Okay, now we're going up in temperature, and at this point we are converted completely to liquid water. So the only cup that looks like all liquid is C, or cup 2. So we match that to C. Now at 100 degrees, we reach the boiling point of water. So we need to find the cup that shows water boiling. So this cup, you can see there's some gas bubbles in it. So this shows us that the water has begun boiling. So that's D. And in E, we have converted completely to a gas. So this cup contains nothing but steam. So this is our E. Okay. So that's it for chapter 3 lecture material.